Well, good morning, pre-cal kids. How's everybody doing here? Just going to go over a couple things here before we start a little bit of the review. Just a slight change here in the weekly schedule, and it just has to do with what time something is due. Monday's the same. We obviously went over the 7-5 notes. Today, Tuesday, April 14th, you're going to do, or I'm going to put up the 7-1 to 7-5 review video notes. Just going to review a few things. The main thing is there will be a review assignment to go over to get ready for the test. The test will be 100 points. And remember, it does go into that 55% bucket, so it's more important than a quiz. Now, the review assignment will be due Wednesday, tomorrow at 6 p.m. Normally it's at midnight, but here's what I want to have is, since the test is Thursday, I want that done by Wednesday so I can at least go through those as much as I can. We will Canvas conference 8 to 8:30 for anybody who needs help today. But then Wednesday, no video notes, nothing official. You need to finish your assignment. It'll be due at 6. It'll be the Canvas conference from 12:30 to 1, and then another from 8 to 8:30. So for those of you who've done it, and I'll also post the answer key at 6 o'clock. So once that answer key is posted, you can go look and see how you did. If you're missing some, if you're not quite sure on others, you can hop on 8 to 8:30. I'll definitely go a little bit longer if needed. That's not a firm ending time, but I just want to make sure you have a window that you can get help in if you need it. And then Thursday, the 7-1 to 7-5 test posted in the morning at 7:30, submitted by 9 a.m. And then Friday, there will be nothing. And then we'll pick back up the following Monday. And there are 2 sections in Chapter 7 to finish, but we'll do those on Monday. All right, that's kind of the agenda. And that slight change here. Here's the review. Now, remember, I am going to put on, once it is due, under modules, if you go back to section 7.4, hold on here a second. Once it is due, I'm going to put the review key up. And so I'm going to do this for all assignments. And so you need to be a little bit disciplined, especially if you were unsure about a few, go back and check. So it's going to be on the video, but I think that's not quite as easy to go over. I mean, obviously you can pause it and come back, but you can pull up the review key. Just to highlight a couple things here, make sure from section, now that should say 7.4, I think yours does. When you are drawing the vector, the resultant vector, the sum, it has to have an arrow in it. Now remember, if you're going u plus z, this is the u vector right here, and this is the z vector. Remember, your resultant vector always starts at wherever your first one started and ends where your second. That's where the arrow goes. So that arrow has to be here. 2v minus w, the arrow has to be here. And then there's your arrow. And you got to make sure it's a little bit clear, okay, for me. And they go through here, position vectors, magnitude. Okay, I think we rounded everything to the nearest 10th on this. We're going to do another problem here today, but make sure you double check this B if this tends to be an issue, and also check A. That's in quadrant 2. This is in quadrant 3. A lot of people on the initial homework had some issues with coming up with the direction. Remember, you are finding the reference angle. You have to figure out what quadrant you're in, and then you have to basically determine the direction off of the x-axis. Okay, same thing here. This direction angle is 211 degrees. Double check what you got. Here's your word problems. I'm not really going to talk through these. It'd take a little long, but go through direction 33.13 degrees, 25,000 pounds. If you round to the nearest 10th, that's fine. And basically on the test, everything's to the nearest 10th with the exception of a couple things. Direction 86.49 degrees, 174.96 pounds. 9, south 11.82 degrees east, 264.01 miles per hour. And then 10, we already went over that one yesterday because of just the way that one is worded. It's a little bit different. 637.89 south, 80.45 degrees west. I'm not sure what that is. Oh, that's if you put the direction. All right, so double check your answers. And then for section 7.5, I'll put those answers up tomorrow morning, which would be Wednesday. So you should have an opportunity to go through all your homework, double check everything. Do check your answers again, the odd ones in the back before you turn in. You should have a good idea. And most of the problems are odd just for that reason. Not all of them, but most of them, just to kind of give you a little bit of heads up, whether you know what you're doing or you need a little bit of help. Okay, all I'm going to do is go over 3 or 4 problems here, just the ones that during the course of the chapter, maybe more than a few people missed. Definitely expect to see something like these on the test. Okay, an airplane has an airspeed of 250 kilometers per hour. It is to make on a flight on a bearing of south 55 degrees west. Well, there's a 35 kilometer per hour wind blowing from the southeast. Okay, from the southeast. So it is coming from this direction. And then the bearing is north 62 degrees west. And we'll go through that a little more accurately here in a second. What will the airplane's actual speed and bearing be? Okay, we're going to round everything to the nearest 10. All right, 250 kilometers per hour. Let me move this up a little bit. And the direction. Is going to be, what is the direction? South 55 degrees west. So we're going to start south, and we're going to go 55 degrees to the west. That means that this angle right here is 55 degrees. All right, so south, but we need the direction. Okay, when we're doing vectors and we're doing the IJ form, we need the direction. And so what is the direction of that? The direction is this angle right here. 55 is here. So take 90 minus 55, and you're going to get 35 for this inside angle. And 180 plus 35, I believe, gives us 215. Here the problem is, without having a class, if I make a mistake, we can go through this whole thing and mess it up. And believe me, as you know, I make mistakes. But you have to have your direction. All right. So now the speed or the wind, it's going to be helpful for me to kind of erase some things as we go. The wind has a bearing of north, 62 degrees west. So I'm going north, and I'm going 62 degrees off of the west. That is 62 degrees. Now, north, 62 degrees west. What is that as a direction? Well, I need the reference angle. The reference angle is 90 minus 62, which is 28 degrees. Now, in this case here, what is my direction going to be? It's going to be 180 minus 28. And that's going to give me 152 degrees. That is my direction. Now, what's the resultant going to look like? Now, if this is 250 and that's 35, clearly I haven't drawn them to scale very well. So I'm just going to, and it's still not going to be to scale, but it'll be a little bit more realistic. And so to get the answer, we add those two together, and I'm just going to slide this one over here because you can see how the wind is going to push the plane and how the wind is going to affect the plane. And this will be our sum. That'll be their U plus V. Okay, so I'm going to call the first one U, which was 250 miles per hour. And then the other one was 35. I'm going to call that V, and then I got to figure out what U plus V is. I have to add them together. All right, let's go through here. U. Now we're going to convert it. We got the magnitude. We have the direction. We're going to convert it to IJ form. Magnitude we use is the speed, 250. And then that's going to be times cosine of 215 degrees I plus sine of 215 degrees J. And then V is going to be 35 times cosine of 152 degrees I plus sine of 152 degrees J. All right, I'm going to pause this. You go ahead and figure out what U is. And I'm just going to go to the nearest tenth. And then figure out what V is. And then while I'm doing that, you do the same. Write down what you got to the nearest tenth, and then do U plus V. Add those two together. So let me hit pause. Okay. All right, I went through and I found U, negative 204.8 minus 143.4, I, and then J. I found V, negative 30.9 I plus 16.4 J. Okay, U plus V, you add the negative 204.8 plus negative 30.9, and I got negative 235.7 I minus 127.0 J when I did the negative 143 plus 16.4. Okay, right now you should think, what quadrant am I in? Now from your drawing, you can get a good idea, but your drawing isn't always 100% accurate. And if you're kind of close to one of the axes, you may think you're in one quadrant when you're actually in the other. But here this tells you for sure if it's a negative and a negative, you have to be in quadrant 3, and that's going to play effect on our bearing and our reference angle. So we got to find the speed. Well, it looks like, according to this, that the wind's actually going to make us go a little bit faster. Okay, it's going to help us. So we're going to take the magnitude, and that's going to be the square root. Negative 235.7 quantity squared plus negative 127.0 quantity squared. I technically really don't need to write the negatives, but I did. So second square root, and I'm going to put an inside parentheses there and just put the whole thing in parentheses. So I got negative 235.7, got to close that parentheses, squared, plus negative 127 quantity squared. And then I'm going to put a parentheses around the whole thing. And I get 267.7. So 267.7. So it does speed us up a little bit. And that makes sense, kilometers per hour, according to the drawing. Now I need, and this is where there's the biggest, I see the biggest mistakes. This is going to be the reference angle. And it's going to be the absolute value of the y coordinate over the x coordinate. And then in this case, when I type into my calculator, I am not going to worry about those negatives. Inverse tangent 127 divided by 235.7. And then I get 28.3 degrees. That is not your direction. That is not your bearing. Understand what's going on here. That is this reference angle for the u plus v vector right there. I want the bearing. Okay, what's the actual speed and bearing that the plane travels? We need to know this angle. This is 28.3 degrees. Take 90 minus that. And that gives me 61.7 degrees. So the bearing will be south, okay, and then 61.7 degrees. And then we are going to the west. Okay, so normally it was, what was the bearing? South 55 degrees west. The wind is pushing us an extra 6.7 degrees. So there's your bearing, there's your speed. Okay, converting to the IJ form. All right, from some of the previous homeworks, there were some issues. Again, this has to do with find the magnitude and direction for the vector. Okay, when it's written in this form, it's a position vector, -4, 9. So that means that that is its endpoint. So there's -4, there's 9. The magnitude is the length of the vector. Okay, the direction is this angle off of the x-axis. That is our direction. Well, the magnitude, that's just the square root of -4 squared plus 9 squared. And for this, we're just going to round everything to the nearest tenth. Any final answer if it doesn't come out to be a whole number. Well, what is that? That is -4 squared is 16. 16 plus 81. So what do we get? Square root of 97. So 16 plus 81. I'm just telling you, I am just nervous about making a stupid mistake. And even though I'm going to double check things, I'm sure at some point I'm going to make a mistake and carry it to the whole problem. And I don't have anybody here to tell me whether I'm right or wrong. And so it's 9.8. Okay. So we got 9.8 degrees. All right, now when we use inverse tangent, absolute value of the y, because basically here, and you don't have to draw this picture out by any means, but I just think that when you have it, it gives you a visual and kind of gives you a little bit of confidence of what you're doing and how your answers are. So that's going to be 9. That's going to be 4 if you think of this as a right triangle. This is the angle that we're finding. So inverse tangent, absolute value 9/4, which is just going to be 9/4. And that gives me 66.0 degrees if I go to the nearest 10. 66.0 degrees. All right, so when you're answering this question, if you could tell me the magnitude is 9.8, that should not be degrees there. Okay. And then the direction is 66.0. That's going to be incorrect. That is not our direction. So we know the magnitude is 66. No, hold on. 9.8. And our direction is going to use the 66. Okay, that is your reference angle. So your direction is going to be 180, the final direction, minus that 66 because we are in quadrant 2. So if we take 180 minus 66, it's going to give me 114 degrees. Okay, so just be careful there. Okay, this is where I saw a lot of mistakes. People just said, 66, that's my direction. But if you draw it out, -4.9 absolutely cannot be. All right, explain why when solving a triangle, given the measure of the 3 sides, you would solve for the largest angle first. Okay, so if you're given 3 sides, let's see if I don't know if I can stretch this one or not. Nope, it's just going to look like that. I thought I had. Well, I can just draw it. So given 3 sides, whatever, this is 15, this is 18, and this is 24. We talked about this before. Why do we want to find? And if I call that angle A, B, and C, now if I want to find angle A first, we want to use law of cosines, which is the only thing we can use. And the law of cosines will give me an obtuse angle. So if this is bigger than 90 degrees, the law of cosines will come back bigger than 90 degrees. If I find one of the other 2 angles and then I use the law of sines to find angle A, it will come back as an acute angle and we will get an incorrect value. Okay, so why do we want to do this? Because the law of cosines will give an obtuse answer. where the law of sines will not. The law of sines will only come back with an acute angle. That's why when we do side-side angle, we want to find the smallest angle next, because we're guaranteed if we use law of sines, it will be acute and we're fine. If you don't, then you're, again, risking possible error. Anytime you use the law of sines to find an angle that could arbitrarily be obtuse, you have to be very careful. All right, let's go through one more. Okay, we got the old ship one. A ship sailing due north at a rate of 16 miles per hour records the bearing of a lighthouse as north 50 degrees east. 2 hours later, the bearing of the same lighthouse is south 72 degrees east. How far is the ship from the lighthouse the second time? Round answers to the nearest tenth of a mile. So we're only going to find it the second time. We're not going to worry about how close it comes for this problem. It's going due north. Okay, let's say the first sighting, we are right here. In the first sighting, the lighthouse is north 50 degrees east. So that means off of this north line, I go 50 degrees. Now, of course, I'm just estimating here, east. So let's say right there, that is my lighthouse. Where's the 50 degrees at? It is right there. Okay, second time. 2 hours later, the bearing of the same lighthouse is south 72 degrees east. Okay, south 72 degrees east. All right, since it is now south, that means that the boat passed the lighthouse. And I'm looking south, and then I'm going 72 degrees. Okay, to the east. That means this angle right here is 72 degrees. And now this is the distance the second time. Now, sometimes in the problem, if it was still north, we would still be below the lighthouse. Here we've passed it. And now that is the south, 72 degrees east for that. We were traveling for 2 hours at 16 miles per hour. 2 times 16 is 32. Okay, I do have those two angles, which are part of the triangle. I need this here. I still need to figure out this angle in order to solve for x, because I'm going to have to use that value. So take 180 minus 72 minus 50, and we get 58 degrees. So that's going to be 58 degrees. So in order to find x, sine of 58 degrees over the opposite side, which is 32, equals the sine of 50 degrees over that x value. So x times sine of 58 equals 32 sine of 50. Divide by sine of 58. And let's see what we get here. 32 times sine of 50 divided by sine of 58, and that is 28.9 and miles. Okay, and that makes sense because 32 is across from 58. This is 50 degrees. It has to be smaller than 32. So it's not going to be a huge amount smaller because the 58 and 50 are relatively close. So that's what we're going to get for 28.9 miles. All right, you do have an assignment here. It is attached to the video notes there, or to the under modules. And a couple things here. On the test, on these review, you're going to have these 1, 2, 3 equations I'm going to give you. And you can manipulate this one and solve it for B or solve it for C, but I'll give you the base equation for here. And so that'll be on your test. Do not use your notes for this. Okay, nothing's out because you're going to give you the assignments. There will be some. Now, if you print it out, there's going to be some problems where you have to draw the vectors. I know some of you don't have printing capabilities. If you got graph paper, then you can do these two or this type of problems on the graph paper. If you print it out, you can do them on here. You're going to have to do the rest of your work on a separate sheet for this assignment, just because there's just not enough room. I didn't leave you enough room. And don't try and jam it all in here. So just do it on a separate sheet. But come test time, there will be a couple problems like 11 and 12. And if you have graph paper, fine. If not, you're going to have to kind of draw some grids and make it the best you can. And I'll be able to tell whether you got it right or wrong for that one. And then there was a couple more problems. So don't save this for the very end. Get this done as soon as you can. Wednesday at 6. Okay, do Wednesday at 6. And then I'll have a Canvas conference at 8 o'clock, and then I'll have the answers posted. All right, everybody have a good day. Hope everything's going well.